Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Welcome to another session of Theory of Machines. In previous sessions, we finished the first chapter. In this session, we are going to start second chapter, that is Velocity and Acceleration Analysis. Velocity and Acceleration Analysis, another important chapter in Theory of Machines. So first let us try to understand what is velocity analysis. All of you may know what is velocity. What is linear velocity? Rate of change of linear displacement is called velocity, right? Linear velocity. So linear velocity V is equal to dx by dt, or I may put E suffix x here, right? Linear velocity of a moving point or moving body along x-axis is dx by dt, rate of change of linear displacement. Similarly, Vy means dy by dt, rate of change of linear displacement along y-axis. Similarly, velocity about z-axis is equal to dz by dt. It is rate of change of linear displacement along z-axis. We all know what is velocity, right? So here x means displacement along x-axis, y means displacement along y-axis, and z means displacement along z-axis. So rate of change of linear displacement is called linear velocity. Similarly, what is angular velocity? The angular velocity is nothing but rate of change of angular displacement. Rate of change of angular displacement is called angular velocity. So everybody knows what is linear velocity and what is angular velocity, right? Now let us try to understand what is velocity analysis. In simple terminology, velocity analysis means computation of velocities of various links of mechanism, or calculation of velocities of various links of mechanism, or various strategic points of existing mechanism. For suppose a mechanism is already existing. For existing mechanism, velocity analysis means calculation of velocities of various links of the mechanism or various strategic points of mechanism. Okay? For existing mechanism, velocity analysis means calculation or computation of velocities of various links or various strategic points. For instance, I am going to design a new mechanism. So currently it is not existing. I am designing now. For a new mechanism which is in design stage, velocity analysis means fixing of velocities for various links of mechanism. Fixing of velocities of various links of the mechanism, or fixing of velocities of various strategic points of mechanism. Okay? For example, a 4-bar mechanism I am designing, a new type of 4-bar mechanism. In 4-bar mechanism there are 4 links. Out of 4 links, 1 link will be fixed link. Remaining 3 links are moving links. For every link, velocity analysis means fixing of velocities of every moving link of mechanism. Fixing of velocities means what is maximum velocity, what is minimum velocity, what is range of velocity. Like that, right? For every link, we have to fix what is highest velocity, what is lowest velocity, what is range of velocity. Velocity in this sense, both the velocities mean linear velocity and angular velocity. So for a new mechanism, velocity analysis means fixing of velocities, both angular and linear velocities of various links or various strategic points of the mechanism. This is what velocity analysis means. Okay? Why we have to perform velocity analysis? A question might be coming to your mind. Why we have to find velocities of various links? Why we have to fix velocities of various links? Right? Why we have to perform velocity analysis? Different applications may require different velocities. Somewhere I need to operate my output link very slowly. Somewhere I may require high speed. Somewhere I may require oscillatory motion, low speed oscillation, sometimes high speed oscillation, right? Sometimes, I may require only linear motion. Sometimes I may require only rotary motion. Sometimes I may require both linear and rotary motions, right? So, different applications may require different velocity sets. So, that is why we have to perform velocity analysis. For instance, wiper mechanism is there. In wiper mechanism, I need to operate wiper with low speed. What is motion of output link of wiper mechanism or wiper? Wiper slowly oscillates like this. Slowly it oscillates. In the process, it may wipe out all the moisture from the windscreen. There my requirement is low speed oscillation. Similarly, in reciprocating compressor mechanism, there I need to operate my input link with constant velocity and I need to operate my output link with high speed linear motion. In reciprocating air compressor mechanism, input link is crank, output link is piston. There I require high speed motion of piston. Somewhere I require high speed rotation, somewhere I may require low speed rotation, somewhere I may require high speed oscillation, somewhere I may require low speed oscillation. Different applications may require different sets of velocities. So that is why we have to fix velocities for the new mechanism. In view of the requirement and for existing mechanism, we have to perform velocity analysis for another purpose, for performing acceleration analysis. We need to perform velocity analysis for performing acceleration analysis, right? So before I dictate what is acceleration analysis, all of you may write what is the meaning of velocity analysis. Please write velocity analysis. Velocity analysis. Velocity analysis. It is the process of fixing velocities. It is the process of fixing velocities. It is the process of fixing velocities of various links. Of various links. Of various links and strategic points. And strategic points. And strategic points. Strategic points for new mechanism. For new mechanism. For new mechanism. Currently it is not available. We are designing it now, right? For new mechanism or calculation of velocities. Calculation of velocities. Calculation of velocities of various links. Calculation of velocities of various links and strategic points. And strategic points. And strategic points for existing mechanism. For existing mechanism. For existing mechanism, it is calculation. For new mechanism, fixing. So either fixing of velocities or calculation of velocities is called as velocity analysis, right? I already told why we have to perform velocity analysis. One reason is different applications may require different velocities. That is why we have to fix certain range of velocities in view of requirement and need. Second requirement is, we have to perform velocity analysis for performing acceleration analysis. Before performing acceleration analysis, we need to perform velocity analysis. What is acceleration analysis? What is acceleration analysis? Name itself is saying it is fixing of accelerations of various lengths and various strategic points for new mechanism, or calculation of acceleration of various lengths and strategic points for existing mechanism. Okay? Velocity analysis, calculation of velocity or fixing a velocities, Acceleration analysis means finding accelerations or fixing accelerations, like that, right? So first you write down what is acceleration analysis, then I will narrate why we have to perform acceleration analysis. Write down, all of you, what is acceleration analysis. Acceleration analysis. Acceleration analysis. It is the process of fixing acceleration. It is the process of fixing acceleration. It is the process of fixing acceleration for various links, for various links, for various links, and various strategic points, for various strategic points, strategic points, strategic points of a new mechanism, of a new mechanism, of a new mechanism, or calculation of acceleration, calculation of acceleration, calculation of acceleration of various links, on strategic points, on strategic points, on strategic points for existing mechanism, for existing mechanism, for existing mechanism. This is what acceleration analysis means. Calculation of accelerations, acceleration in the sense linear acceleration, angular accelerations, absolute acceleration, relative acceleration, like that, man, right? So this is what acceleration analysis means. Now, why we have to perform acceleration analysis? Acceleration analysis is required for performing force analysis. Acceleration analysis is required for performing force analysis. Force analysis. What is force analysis? Force analysis means calculation of forces carried by various links of mechanism, or fixing of forces for various links of mechanism is called force analysis. For existing mechanism, it is calculation of forces. For new mechanism, you have to fix what is highest force on a particular link in a cycle of operation. What is lowest link? What is highest turning moment? What is lowest turning moment? So fixing of forces and turning moments of various links for new mechanism, or calculation of force carried by each link and turning moment carried by each link of existing mechanism is called force analysis. Okay, so first we are starting with velocity analysis, then acceleration analysis. For getting acceleration, and first you have to perform velocity analysis. For performing acceleration analysis, first you need to perform velocity analysis. So after acceleration analysis, you could perform force analysis, right? Write down first what is force analysis, then I will tell you why we have to perform force analysis and why we require accelerations for performing force analysis. All of you write what is force analysis. It is process of fixing. It is process of fixing force and turning moment. It is the process of fixing force and turning moment for various links, for various links, for various links of a new mechanism, of a new mechanism, of a new mechanism or calculation of force and turning moment, calculation of force and turning moment, calculation of force and turning moment of various links of existing mechanism. For new mechanism it is fixing, for existing mechanism it is calculation. Like that we can understand. This is force analysis, right? All of us know force is equal to mass into acceleration, turning moment is equal to I into alpha. Force is equal to mass into acceleration, turning moment is equal to moment of inertia into angular acceleration. For finding force, you require acceleration. From where you will get acceleration? From acceleration analysis, I could find acceleration of various links. Similarly, turning moment is equal to I into alpha. For finding turning moment, first I need to know acceleration, angular acceleration of links. From where I can get this data? I can get angular acceleration data from acceleration analysis. So I can say like this, man, acceleration analysis is required, right, for performing force analysis. I may say like this, velocity analysis is required for acceleration analysis. Acceleration analysis is required for force analysis. Without acceleration analysis, you cannot perform force analysis. So before force analysis, we need to perform acceleration analysis. Now we may get some doubt. Why I need to find forces and turning moments carried by various links? Why I need to find all these things? Why I need to find what is highest force, what is lowest force, highest turning moment, lowest turning moment of link in a cycle of operation? Why I need to find all these things, right? There are many reasons, man, right? There are many reasons. Certain applications may require certain turning moment. Some applications may require high turning moment. Some applications may require low turning moment. In all toggle mechanisms, I require very high turning moment. In all lifting mechanisms, I require large turning moment. So some applications may require large turning moment. Some applications may require small turning moment. Some applications may require large forces. Some applications may require small forces. It's all depending upon requirement, man. What is my need? What is my requirement? Okay? Right. There is another reason for performing force analysis, man, right? There is another reason. Try to think about stress analysis. How do you find, what is stress analysis? Stress analysis means, calculation of stress carried by each link of the mechanism. Calculation of stress carried by each link of the mechanism is called stress analysis. So from where you will get stress? All of us know in many cases stress means resisting force by area, right? Unless you know force, you cannot find stress. So we need to perform force analysis for performing stress analysis. We need to perform force analysis for performing stress analysis. Stress analysis, man. You may get, doubt, man. Why we need to find stresses carried by each link? I need to find stresses to fix size of the link. More stress means more size I have to put. More stress means I need to use, strong materials. We have to perform stress analysis for designing of links. What is the size of the link? What is cross section of the link? What material I have to use? With what surface finish I have to use, right? All these things I can fix from stress analysis. Okay? So, stress analysis follows force analysis. Unless you perform force analysis, you cannot perform stress analysis. Unless you perform stress analysis, you cannot fix size of the links, both cross-sectional parameters, surface parameters, material parameters, strength parameters, right? For fixing all these things, we require stress analysis. Okay? So we need to perform force analysis for performing stress analysis. So all of you please write, what is stress analysis? Okay? What is stress analysis? It is process of calculation of stresses. It is process of calculation of stresses carried by various links of mechanism. Various links of mechanism. This is what stress analysis means. Stress analysis is required for fixing various dimensions, materials, etc., of the mechanism, right? So this is stress analysis. And another point I can derive from force analysis. Force analysis tells you whether all forces are balanced or not. Force analysis tells you whether all turning moments are balanced or not. Right? Try to listen carefully here. If forces are not balanced, if any unbalanced force is there in mechanism, it may result into vibrations. If any unbalanced turning moment is present in mechanism, that unbalanced turning moment may induce vibrations. Vibrations primarily come because of either unbalanced force or unbalanced couple. How do you find whether forces are balanced or unbalanced, couples are balanced or unbalanced? I can say from force analysis, man. By performing force analysis, I came to understand, whether all forces are balanced, all turning moments are balanced or not. Okay? So, for performing vibrational analysis, first you have to perform force analysis, man. Without performing force analysis, you cannot perform vibrational analysis. Why? Because vibrations primarily come because of either unbalanced force or unbalanced couples. So you may understand the sequence, man, right? First velocity analysis, then acceleration analysis, then force analysis, then vibrational analysis. Okay? Right. Why do you find vibrational analysis? Why we have to find various parameters of vibrations? Vibrational analysis primarily includes 2-3 things, man, right? In vibrational analysis, we usually find what is natural frequency of the vibration and what is the amplitude of vibration, and whether damping is present or not in the system. If damping is present, so what is amplitude of the vibration and how it is decreasing, whether it is decreasing or not. If it decreases, how it is decreasing, whether linearly it is decreasing or exponentially it is decreasing. All these things we find in vibrational analysis. But simply saying, in vibrational analysis, primarily we find, right, 3 things. What is natural frequency? Second, what is amplitude? And third, what is amplitude decay? With every cycle, how much amplitude is decreasing and how it is decreasing. These things we find in vibrational analysis. So vibrations is a separate chapter. There I will define what is vibration, right? What are different types of vibrations? What is vibrational analysis? All these things we discuss in vibrations, right? So for performing vibrational analysis, first I need to perform what analysis? I need to perform force analysis, man. First I should know forces carried by links, turning moments carried by links. Then I can understand whether all forces are balanced or not, all turning moments are balanced or not. If anything is not balanced, definitely vibration will start. Vibration comes primarily because of unbalanced force and unbalanced couple. Okay? But what is starting point for all these things? Starting point is Velocity analysis, man. Okay, so never forget it. Now, after performing vibrational analysis, what I do by performing vibrational analysis. Okay, if any machine is vibrating, if any engine is vibrating, you have to understand forces are not balanced, couples are not balanced. When forces are not balanced or couples are not balanced, what we have to do? We have to conduct balancing. We have to balance the engine. We have to balance the machine. We have to balance unbalanced force. We have to balance unbalanced couple. This is called balancing, man. So I may define balancing like this. Balancing, it is the process of eliminating, unbalanced force and unbalanced couple either by adding mass or subtracting mass. Okay? So, for performing balancing, first you have to perform vibrational analysis, man. If there is no vibration, you need not balance that machine, man, right? No vibration means no unbalanced force, no unbalanced couple. You need not perform balancing for that machine or engine. When vibration is there in machine or engine, you have to understand there is some force which is not balanced. There is some moment that is not balanced. So by using balancing process, we balance various unbalanced forces and unbalanced couples. Okay? So all of you may write, I may give you a small definition on vibrational analysis and balancing. We extensively study vibrational analysis in vibrations and balancing in balancing chapter, right? There is a separate chapter which is called balancing. There you will understand what are different kinds of balancing, etc., etc. But currently just I want to give a basic definition of vibrational analysis and balancing, right? So first you may write vibrational analysis. Vibrational analysis. It is the process of finding. It is the process of finding. It is the process of finding natural frequency. Second, amplitude of vibration, and third, frequency of vibration, then fourth, amplitude decay, right? For every cycle, amplitude of vibration tends to decrease, right? Amplitude decay and mode of amplitude decay, and last, mode shape of vibration. In vibrational analysis, generally we find these things, man, right? There are several other parameters, but these are basic parameters or fundamental parameters, right? These parameters we generally find in vibrational analysis. Please copy this. Of course, there is a separate chapter which is called vibration. There we study vibrations extensively. Currently, a brief view of vibrations, a glimpse of vibration, right? So all of you copy these things. I hope you copied. Now next you may write what is balancing, right? Balancing succeeds vibrational analysis, right? Write down what is balancing. Only definition I am giving, right? There is a separate chapter which is called balancing. There we study balancing extensively, right? Balancing. Balancing. It is the process of eliminating. It is the process of eliminating unbalanced forces and unbalanced couples. Unbalanced forces and unbalanced couples by adding or subtracting masses. By adding or subtracting masses. So this activity is called balancing, man, right? And you have to understand all these analyses are starting with velocity analysis, man. Velocity analysis forms basis for all these analysis. The starting point of all analysis of mechanism is velocity analysis. Okay? So, in coming 2-3 sessions, I will concentrate on only velocity analysis, but before that, just I want to write sequence of analysis. First velocity analysis, then it is followed by acceleration analysis. It is followed by acceleration analysis, and it is followed by force analysis. And this force analysis is followed by 2 analysis. One analysis is stress analysis, and second analysis is vibrational analysis. Vibrational analysis, right? And this vibrational analysis is finally followed by balancing. Finally, it is followed by balancing. Starting point is, velocity analysis. Last point is balancing, right? So a question came in IAS on sequence. What is sequence of analysis of a mechanism? Like that they asked. So first velocity analysis, then acceleration analysis, then force analysis, then vibrational analysis, then balancing. So this is the sequence of analysis of any mechanism. Okay? Now, in velocity analysis, there are 2 basic terms. First is synthesis, and second is analysis. Of course, in kinematics, these are the 2 basic terms, synthesis and analysis. What is synthesis? What is analysis? So every mechanical engineering student should understand what is the meaning of synthesis, what is the meaning of analysis. All of you right now, synthesis, right? Synthesis. It is process of fixing. It is the process of fixing motions, velocities, motions, velocities, accelerations, of a new mechanism. So this is called the synthesis, man, right? What is analysis? Synthesis is performed for new mechanism. Analysis is performed for existing mechanism, man, right? Already we understood what is velocity analysis, what is acceleration analysis, force analysis. In analysis, you will find all these things, man. Right? Then what is analysis? It is the process of finding. It is the process of finding velocities, accelerations, forces of existing mechanism. You know, if I say force, you have to understand turning moment also, man. Rotating force is called turning moment, right? You have to understand force means force and turning moment. Okay, this is analysis, man, right? So now in coming 2-3 sessions, I am going to spend only time on velocity analysis, right? So velocity analysis is performed by using various methodologies, man, right? Velocity analysis is performed by using various methodologies. First method is analytical method. It is also called as formula method. And second method is graphical method. In graphical method, again, there are 2 methods. First method is relative velocity method. It is also called as vector method. And second method is instantaneous center method. Instantaneous center method is also called as IC method, right? Instantaneous center method. So we can perform velocity analysis of a mechanism in these methods, right? First is analytical method or formula method. Second is graphical method. In graphical method, there are 2 ways again: relative velocity method, and next is instantaneous center method or IC method, right? We are going to use this analytical method in a separate chapter, man. We are having a chapter called dynamic force analysis of single slider crank mechanism. There we are going to implement analytical method, right? And of course, analytical method is based on formula, man. Some formulae may present for velocities of various links of mechanism. For example, single slider crank mechanism, right? So one formula will be there for velocity of piston, another formula will be there for velocity of connecting rod, another formula will be there for velocity of crank, right? So formulae are available for various links. By using those formulae, you can find velocities of various links of mechanism. So this is what analytical method means. But analytical method you cannot implement for every mechanism. For simple mechanisms only, analytical method is present. For every mechanism, you cannot use analytical method, and you cannot have formulae, because every mechanism is a distinct, it may have distinct velocities and accelerations. You cannot standardize velocities for every mechanism, right? So for very few simple mechanisms, we may use analytical method, and I'm going to use this method in dynamic force analysis of single slider crank mechanism chapter. Right now, we are not going to worry about this analytical method. Now, we are going to follow these 2 methods now: relative velocity method and instantaneous center method. Okay, so a brief introduction on relative velocity method and instantaneous center method. You can use relative velocity method for any kind of mechanism, either simple mechanism, compound mechanism, complex mechanism. For any mechanism, you can use relative velocity method or vector method. Okay. Now, second is instantaneous center method. Instantaneous center method is generally used for simple mechanisms only. If number of links is few, you may follow IC method, instantaneous center method. If number of links are more, instantaneous center method may become laborious, it may become cumbersome method. As number of links increase, number of instantaneous centers also will increase. So fixing instantaneous centers itself become very lengthy process. So you can use the relative velocity method for any kind of mechanism, but you can use instantaneous center method for simple mechanisms carrying less number of links, right? And the second point, relative velocity method. By using relative velocity method, we draw velocity diagrams or vector diagrams. Those diagrams are required for acceleration analysis. If you want to perform acceleration analysis, you require data of velocity of various links. From where I can get that data? From relative velocity method. In relative velocity method, we draw velocity diagrams, or vector diagrams of velocities. From there, I can read various velocities and consequently I can perform acceleration analysis. If you want to perform acceleration analysis also, you need to follow relative velocity method, right? So relative velocity method allows you to perform acceleration analysis also. But instantaneous center method, right? If you want to perform acceleration analysis also, this method may not be suitable. Instantaneous center method may not be suitable because by using instantaneous center method, you cannot find various accelerations of mechanism. That is drawback of instantaneous center method. But there is one good news with respect to instantaneous center method, right? For instance, a mechanism is there. In that mechanism, there are 12 number of links. 12 number of links. Velocity of second link is given. I need to find velocity of ninth link. Velocity of second link is given. Velocity of ninth link I have to find. In relative velocity method, for finding velocity of ninth link, you need to find velocities of all intermediate links between second link and ninth link. In relative velocity method, for finding velocity of ninth link from velocity of second link, you need to find velocity of all intermediate links from second link to ninth link, perhaps third link, fourth link, fifth link, sixth link, seventh link. For every link you have to find velocities. Then only finally you will get velocity of ninth link. Or for instance, in the mechanism 12 links are there. Velocity of link 2 is given. I want to find velocity of 13th link. In relative velocity method, to find velocity of 12th link, you need to find velocity of all intermediate links between second link and 12th link. You cannot bypass velocities of various intermediate links. But in instantaneous center method, directly you can find velocity of any link from velocity of any other link. For instance, angular velocity of second link is given. I want to find angular velocity of seventh link. I can find, directly I can find velocity of second link from velocity of second link, right? Without finding velocities of omega 3, omega 4, omega 5 or intermediate links. In instantaneous center method, I can bypass intermediate links. Okay, I can bypass intermediate links. So I can find velocity of any link from velocity of any link. That is beauty of instantaneous center method. Now, as far as gate is concerned, which is more important method? Relative velocity method or instantaneous center method? Definitely I should say, as far as gate is concerned, instantaneous center method is more important than relative velocity method. Many questions are coming from instantaneous center method rather than relative velocity method. For our knowledge, we are going to deal both the methods, right? Relative velocity method as well as instantaneous center method. But as far as gate is concerned, you need to focus more on instantaneous center method. So in our gate classes also, we are going to spend more time on instantaneous center method than relative velocity method. Some questions are coming on relative velocity method also, but not frequently. But on instantaneous center method, frequently questions are coming. Okay, you cannot escape instantaneous center method. So what I'm saying, focus more on instantaneous center method rather than relative velocity method. For relative velocity method, 2-3 times just go through it. There is more than enough. But you cannot escape, right, the instantaneous center method. Because in gate exam, continuously questions are coming on instantaneous center method. Okay. So here I told advantage of relative velocity method, advantage of instantaneous center method, drawback of relative velocity method, drawback of instantaneous center method, and which method is important for our gate. Okay. So this is end of introductory session on velocity and acceleration analysis. Okay. In coming session, I am going to start relative velocity method. After completion of relative velocity method, I may start instantaneous center method. After velocity analysis, we pursue even acceleration analysis. Not only acceleration analysis, we are going to perform force analysis also for some mechanisms, right? So this is end of session. In coming session, we meet with relative velocity method of velocity analysis of mechanisms. Until next session, have a great day. Thank you.